On November 12, 1942, in Richmond, California, a fully constructed cargo ship measuring 441 feet in length and weighing 28,490,000 was prepared to launch into San Francisco Bay through the gates of Permanente Metals Corporation's Yard No. 2. This vessel had been put together in merely 4 days, 15 hours, and 29 minutes. Traditionally, master builders in established shipyards had taken anywhere from 6 to 8 months to assemble ships of comparable size since before the era of the American Revolution. However, at this location, a finished Liberty ship awaited deployment. More than 1,000 employees moved away from the hull of the SS Robert E. Peary. These were not conventional shipwrights or seasoned maritime workers, but instead former office secretaries, agricultural workers, homemakers, and manual laborers who had only recently acquired welding skills weeks before. Officials, members of the press, and rival shipyard leaders had assembled to observe an event that would spark a significant shift in the world of industrial production. This marked the start of a system-wide revolution in American manufacturing innovation, the effects of which would resonate for decades. The calculations of Allied triumph were being crafted not through military tactics, but rather in production figures that would upend everything maritime specialists believed about shipping construction boundaries, assembly timetables, and what industry could achieve. The shift began on December 27, 1940, when Henry J. Kaiser inked his inaugural shipbuilding agreement. He was a man who had never overseen ship construction, had never run a shipyard, and whose experience lay in earthmoving and casting concrete for massive dam works throughout the western United States. Nevertheless, a 58-year-old tycoon in the construction sector now stood before the United States Maritime Commission with a pledge to build 30 cargo ships for the British within a 2-year window. The veteran shipbuilders viewed him as an inexperienced opportunist. The Todd Bath Iron Works, amongst America's most venerable shipbuilding firms, had hesitantly agreed to collaborate with Kaiser on the endeavor, believing that their proficiency would offset his lack of familiarity. What they all failed to recognize was that Kaiser's absence of shipbuilding expertise would end up being his most significant strength. Among the onlookers was William Francis Gibbs, recognized as the most esteemed naval architect in America, whose company Gibbs and Cox had developed the Liberty ship blueprints based on British models. He had been responsible for designing more ships than Kaiser had likely ever witnessed. The transformation from doubt to innovation originated in the design offices at Todd Shipyards in New York. As Kaiser and his engineering team reviewed customary shipbuilding techniques in the early months of 1941, they quickly realized that these standard approaches would fall short of fulfilling the needs of war. Kaiser's principal engineer, Clay Bedford, had toured a Ford Motor Company production line in Detroit only weeks prior. Bedford observed as automobile frames advanced along assembly lines, with laborers adding pre-made parts at every workstation. Upon his return to California, he felt certain that ships could be constructed following a similar method. The established shipbuilding community viewed this analogy as preposterous. The initial major surprise arose when Kaiser suggested doing away with riveting altogether. In standard shipbuilding, rivets, hot metal pins driven through overlapping steel sheets to bind them were essential. An experienced team of riveters, operating in perfect harmony, could perhaps fit 100 rivets in a day. A conventional Liberty ship needed about 1 million rivets to be completed. Instead, Kaiser advocated for the use of electric arc welding, a method he had perfected during the construction of pipelines throughout the western United States. Vice Admiral Emory Land, who chaired the United States Maritime Commission, regarded Kaiser's plan with marked suspicion. His personal letters, now part of the National Archives, documented how the maritime community responded. Welding has never yet been shown to be trustworthy for hull building on such a scale. The Royal Navy of Britain prohibits welding on the hulls of its warships. Kaiser is suggesting we gamble America's logistics on a technology that hasn't been proven. Still, Land also saw signs of urgency. German U-boats and surface raiders were destroying Allied vessels quicker than conventional shipbuilders could replace them. In the year 1941 alone, An estimated 3.6 million tons of Allied shipping would wind up at the bottom of the sea for all reasons. Britain was suffering from extreme shortages. Using existing building techniques, American shipyards would take on average 230 days to finish each cargo vessel. At that rate, the Allies would lose control of the Battle of the Atlantic before American manufacturing could react. The choice to grant Kaiser's contract signified not faith, but sheer necessity. The Richmond shipyard sprang up from barren mudflats between January and December of 1941. Workers under Kaiser's direction, who were already adept at constructing dams and highways, built a facility that appalled traditional shipbuilding engineers. In place of the giant gantry cranes and lengthwise building ways found in standard shipyards, Richmond offered something completely distinct. The facility was organized similarly to a car assembly line. Prefabrication zones ringed 7 side-by-side building ways. Rail lines wove throughout the site, intended to transport massive steel components that could weigh as much as 150 tons. Every 100 feet, overhead cranes with the strength to hoist entire portions of ships were installed. John Riley, Bethlehem Steel Corporation's chief naval architect and a shipbuilding expert of 3 decades, toured Richmond's yard in May 1941. His evaluation, stamped confidential at the time, relayed both technical disapproval and reluctant respect. Kaiser has disregarded every rule of effective shipyard design I have learned in 30 years of practice. The prefabrication spaces are oversized. The capacity of the cranes borders on the ridiculous. The building ways lack sufficient length. Nevertheless, I must recognize the yard is built for the precise purpose Kaiser claims, the speedy assembling of pre-made sections. The influx of laborers marked the subsequent stage of dramatic innovation. Established shipyards drew recruits from long-standing maritime towns where expertise was handed down from fathers to sons through the generations. Kaiser placed advertisements in newspapers nationwide, offering pay 20% higher than prevailing industrial wages and vowing to train anyone ready to be employed. The earliest contingents reached Richmond in August of 1941. Adapting the breakdown of intricate tasks into repetitive, straightforward actions, a method taken straight from assembly line production, turned out to be extremely successful. By October 1941, over 10,000 employees were working for Kaiser in Richmond, and under 200 of them possessed any prior background in maritime work. Traditionally, welders would undergo a 4-year apprenticeship to master all-encompassing skills. Kaiser's teaching staff trained workers in particular techniques focused on particular jobs within about 2 weeks. Employees only needed to master how to weld vertical seams on bulkheads, horizontal seams on deck plates, or curved seams on hull parts, tasks they would repeat again and again. As these laborers accumulated skill from late 1941 into early 1942, something unexpected took place. The time needed to build each Liberty ship started to decrease sharply. Kaiser's initial Liberty ship required 197 days for construction and delivery. The second ship was completed in 169 days. Ship number 5 only took 128 days. The 10th ship needed just 97 days. By the spring of 1942, the Richmond site was averaging 70 days to finish a Liberty ship. Established shipyards began observing with increased concern as this mostly inexperienced labor force reached production rates rivaling those of their best-trained crews. The modular construction approach, dismissed by established companies, validated its effectiveness. Rather than assembling ships sequentially from keel to deck, the Kaiser yards put together whole segments at the same time in different parts of the plant. At the same moment one team was building the bow in the prefabrication zone, other teams were constructing sterns, deckhouses, engine areas, and bulkheads concurrently. Once components were ready, huge cranes would transfer them to the assembly slipways where welders fused the parts together.